All right, here we are. We're going to deal with some inequalities, and wanted a couple weird things to happen in here just because it's algebra 2. So when you look at the first one, notice we already have some like terms going on here. So I want to go ahead and put those guys together before we do anything else. So we have 1 plus 9m is less than negative 17. So that's pretty good. And now that I have a single variable, now I want to start moving things side to side. So that's always a good rule of thumb. So we're going to subtract the 1. So I get 9m is less than negative 18. Look, that's going to be beautiful because we're going to divide by 9. So m is less than negative 2. Notice it does fall on my number line here. So I want to make sure that if you're provided a number line, unless I or the somebody made a mistake, your answer should fall on there. So a couple things to remember: that it is less than, so that means it's going to be an open circle here. So I'm going to make that really big to make it super obvious, right? Your teacher's getting a little bit old here, so help me out. And less than negative 2 would be negative 3, negative 4. So we're going to go to the left. So that makes that easy peasy with some lemons if you want to squeeze them. All right, so number 2. So first one was a little extra with the like terms. Next one I have like terms again. So I get n minus 2n. So that's negative 1n is greater than 4. All right, so we had some time off. So I want to make sure I write that as negative 1n. And this is what we have to deal with today. If I divide by a negative, or if any other case, if I multiply by a negative, this is the thing to remember about your inequalities, is we need to flip over that sign. So n is now less than negative 4. And notice it does fall on my graph. So that's a real telltale sign that it helped me out. So less than, again, is still going to be to the left. And we're going to deal with it that way. All right, so we get a couple others to take a look at. So it looks like we're finally going to get a greater than or equal to. Maybe it turns into less than or equal to, but the key is that equals to part. So we'll talk through that in just a second here. So negative 6r minus 2r, well, that's negative 4r. It has to be greater than or equal to 0. We're going to divide by negative 4, which numerically isn't going to make a difference, but I am dividing by a negative. So it now becomes less than or equal to 0. So that is my algebraic answer. We're going to transfer this guy over. Again, now it has an equals to. So that means this 0 counts. And we want to go less than, so we're going to the left. All right, so we want to notice that difference. Remember that from Algebra 1. Equals to means that point counts. We'll deal with that again when we get to graphing lines. Remember solid lines and dashed lines. So now that you're in Algebra 2, we can work that idea backwards just a little bit. Again, as you look at number 4, I want to make sure that I put my like terms together. It is 8 minus 1, so we're at 7x minus 3. I'm going to keep my less than or equal to negative 10 sign. We're going to add 3 and add 3. So I have 7x is greater than or equal to negative 7. Divide by 7. Now I want to be careful that x is on the right, so I still want to write this in this manner. I divided by a plain old 7, so I'm not going to flip this around. So if I read from the x, x is greater than or equal to negative 1. Well, negative 1s are right in the center of that whole thing, so it's kind of a giveaway. And it doesn't mean it's always going to happen that way, but I feel good about my answer. X is greater than or equal to, so equals to, nice big solid point for your old math teacher, right? I didn't have to put my glasses on for this one because I zoomed in. All right, here we go. Now my like terms are the constants here, negative 6 and negative 5. So n minus 11 is less than negative 18. We're just going to add 11. Okay, so I'm thinking in my head, what's going to happen here is I'm going to get negative 7, right? And that falls right on my number line. This time we're just going to be less than, so I'm going to go back to that open circle. So I'm going to be careful with those and shade to the left because it's less than. Right? So think about that. What's less than negative 7? Negative 8 is less than negative 9. Right? It's kind of like what's worse than owing $7, owing 8, owing 9, owing 10. A lot of times when we think about money, it straightens out some of those ideas. All right, so like terms are on the right. So 4 is going to be less than, it looks like negative 2 with a b. All right, so this is not too bad. We're just going to divide by negative 2. And what rule am I trying to get you to remember here? Flip-flop, right? So we're going to flip-flop that inequality to see what happens next. So we want to make sure we have an open circle at negative 2. And I'm going to read it from the b. b is less than -2. So I'm going to go less than one more time and see what happens with it. All right, and just previewing the next question here. Right. And now that you're Algebra 2 kids, I really want to try and stress this along here. As I look at this problem, what I'd really want to do is see if 126 is divisible by 6. Instead of distributing this in and making all the numbers larger, if I can simply divide this first, that's going to make me so much happier. Okay. But I am dividing by a -6. All right, so let's break this down. What's 12 divided by 6? It's 2. What's 6 divided by 6? It's 1. So look how nice that was. We're also going to flip-flop the inequality, right, because it divided by a negative, and now it should be 5 plus 4x. Right, so if you want to distribute it in, that's fine. Okay, I'm not going to stop you from doing it, but it's my job to make sure I point this out to you to say, you know what, this could be easier. Let's subtract the 5. Oop, there it goes. That never gets old to me. I think it's because I am old. That's cool. Remember, I get to say that, not you. All right, so we finish it out. We're going to subtract the 5. We're going to divide by 4. I do not change the inequality because I divided by regular 4, positive 4. X is greater than 4. So 4, here it is. Open and greater than. So we finally went to the right here. All right, let's see, order of operations here. First thing I have to do is get rid of this 3. So I'm going to squeeze that up here so I have a little more space down here. So I have 7 times a plus 6. I just subtracted 3, so I'm not changing any inequalities. 101 minus 3 puts me, what, 98. All right, now, is 98 divisible by 7? I'm going to take a gander that it sure is. Okay, right, because how many times does 7 go into 9? It's 1 time. There's going to be a 2 left over. So now I'm thinking this is 28. So that's 4. All right. So you can kind of use that idea. I want to make sure I keep track of what's left over, and that's how I show it. So hopefully, you know, we're doing inequalities, but if there's something else I do that helps you out, then that's just a bonus. All right. That was divided by a positive 7, so I didn't change anything. Just kind of review my steps here as I have them on there. Subtracting the 6. So a is less than or equal to, that would only get me to what, 8? All right, look at that, 8's right there on my screen. I want to make sure that this guy right here is solid because it is an equals to, and a is less than. So we're going to the left. So a lot of less than in this lesson. Hopefully most of it was a review and you feel pretty good about it. Otherwise, we'll work on it some more in class.